Okay, so I thought I would start by giving you an overview of what Webometrics is. So I assume that the majority of the audience haven't heard of it, or maybe have heard a little bit about it. So I'll start with a general introduction, and then you can get used to my Wolverhampton accent from the middle of England as well. The place in England which has the accent that makes you sound most stupid, in case you're wondering. Okay, so first of all, what is Webometrics? Well, it's a field, a research field within information science, within the discipline of information science, that's focused on gathering data from the web and analysing the data from the web with quantitative methods. So it's really a methods-oriented field, research field, and I'm interested in today the extent to which the outputs of this research field have been adopted in the wider social sciences. So this is a research field that produces things, methods, techniques for analysis, software that are designed to be widely useful in the social sciences. So the question is, does it get picked up in the social sciences or not? Okay, so history of the research field. So it was developed by, it was born with the work of Thomas Ullmind and Peter Ingwersen in 1997. So it's had really a long time. It's had 15 years of analysing web data. So it's had plenty of time to be picked up on by other fields, by other disciplines in the social sciences. And really the starting point for webmetric research was the realisation that you could use search engines, commercial search engines like Google today, to give you data about large-scale analysis of text. So you can get information about the billions of web pages by typing in searches into Google, other search engines. And at the time, although it's not possible anymore now, at the time you could analyse the hyperlinks between collections of pages by typing clever searches into the search engines of the day. So you could get network information from the web. So you could use the web itself as a data source to do huge-scale research, and you didn't need huge-scale budgets to deal with the data because you could use search engines to access that data. So information science research has really been characterised by trying to analyse large quantities of data, by not trying to develop techniques for gathering and storing really huge quantities of data. So I think we've typically dealt with medium-sized amounts of data rather than huge quantities of data. Okay, so I'm going to illustrate some of the techniques that have come out of Webometrics and try and make the case that they're techniques that have wider uses in the social sciences. So this is an example, a simple technique of using search engines to illustrate the connectivity between a set of countries. So here the graph illustrates the strongest interlinking between the universities of European countries. So this graph was drawn by getting 42 countries of Europe and the websites of the universities of the 42 countries of Europe. This was the longest part of the process, identifying all the websites of the 42 countries of Europe, which meant finding websites that list university homepages, not visiting them all individually, I hasten to add. So it took a few days, maybe a couple of weeks altogether, to get the list together and formatted so that we could process it. And then we asked AltaVista at the time, how many links are there between this university and this university? And we collated all the results together, 2 days of submitting queries to AltaVista automatically, and produced this graph. So this graph shows the countries in which the universities most strongly connect to each other. So if you look at this graph, you can see the pattern is really a geopolitical connection pattern. Countries, universities disproportionately linked to other countries that they share a border with and share a common language with. So it's an example of really huge scale research. All the websites of all the countries in Europe with minimal kind of computing input, because we're harnessing what the search engines give us for free in terms of the data. So this is similar techniques are used in the social sciences, which I'll come back to later. Here's another example of data which comes from submitting queries to search engines. So I think this one was Yahoo, or Yahoo if you're American. And this was part of a project to investigate the internationality of life science research groups in Europe. So it was a European-funded initiative to try and find out whether life science research was international or national in focus around the various countries in Europe. And we used the web to do that by identifying the websites of life science research groups in European countries and then finding out where the links come from to those research group websites. So we would regard a country as national in focus if the hyperlinks to the home pages of the life science research groups in that country tended to come from the same country, and we call it international if they came from the rest of the world. So, hope no Hungarians in the audience, no economists, no Hungarians. Oh, sorry. So the result is mainly Hungarian. All the domain names, almost all the domain names end in .hu for Hungary. So you can see that Hungary is has a very nationally focused life science research output. No one else really cares about it, apart from an Austrian portal. And as we produced a similar graph for the countries of Europe, and there were the German graph, for example, looked completely different, very international. So you could really tell with this large-scale analysis with simple tools, search engines, you could tell the international patterns of connectivity for life science research groups. So I think this technique is widely applicable because although we applied it to universities, it can apply to anything that has a presence on the web. You can look for international patterns. And in this case, we weren't really interested in the web at all. We used the web as a convenient way of getting the large-scale data. So we could do the same analysis using other approaches like bibliometric data, and we did do that, but it takes a lot longer and it's expensive. You have to pay for the data from the ISI to do this. So another example. So this is Twitter data, analysis of Twitter. So this is from a project that analysed Twitter over 1 month to look for large-scale changes in sentiment in relation to popular events in Twitter. So what we did for this project is we looked at the 30 biggest things that happened in Twitter over a period of a month, and we judged the size of a thing happening in Twitter by the size of the spike. So this was the Chile earthquake was one of our things, and that generated a huge spike from nothing. So each spike is associated with one or a small number of keywords that describe the topic. So this is the Chile earthquake spike. And so I've given you this is a nice simple graph, the proportion of tweets that mention Chile, which went up to just under 3%. And this is my horrible, complicated, nasty graph to show I can produce horrible, complicated, nasty graphs. The red line is the proportion of tweets that, or the average strength of tweets mentioning Chile, the average positive sentiment strength in tweets mentioning Chile. So it's a sentiment analysis graph. So this is from automatic sentiment analysis of all tweets mentioning Chile. So you can see that the positivity for Chile is low, but decreases radically when the earthquake happens, and then increases a little bit. And the negativity is low and then increases very slightly when the earthquake happens. So this graph is an example of large-scale data, automatic analysis of large-scale data with the aid of a sentiment analysis in this case, but to tackle a social sciences issue. And the social sciences issue was to investigate really Twitter itself. So what's the sentiment orientation of reactions to big events in Twitter? So we wanted to know if you could see from Twitter what people feel about things that are happening in the wider world. And the answer was really no, unfortunately. So we put a lot of effort into this, and So you would think, well, I would think, call me silly, but I would think a big event like the Chilean earthquake, where lots of people died, it was a big tragedy, and there was coverage of how people had died, and and how many deaths there were. I would think that this would be associated with a huge outpouring of emotion in Twitter, with people saying this is terrible. I'm really upset about the news in Chile, but this isn't a huge outpouring of emotion. This is just a tiny little blip of about 6% increase in negative sentiment, in people feeling negative about Chile. So, and this was common to the top 30 events that we looked at. The typical reaction was a small increase in negativity and not a big increase in negativity. And we think it was because in Twitter the sentiment is actually implicit rather than explicit. So if you say there's been an earthquake in Chile, you don't have to say, in Twitter, you don't have to say, and I'm very upset about it. Maybe if you're writing a blog post, then you would say, I'm really upset about it, and this is why, and I hope they're okay, you've got plenty of time. But in Twitter, people seem to just say the facts, and their followers, or they expect their followers to understand that they've said there's been an earthquake in Chile because they think it's important and have had an emotional reaction to it. But it seems to be very, very British understated emotion in Twitter, even though it's predominantly American data. So another example of large-scale analysis of web-based data to address social sciences issues. And one final example. So this is a graph of the friend network in YouTube. So this seems to be something that's really fun to analyse that not many people have picked up on yet. If you look at any YouTube video, you can analyse the comments on it to understand how people have reacted to the video and how they discuss the content of the video amongst themselves. And there are some webmetric tools where you can press a few buttons and it will draw a picture of the commenters on any particular video. So this is one random video, and this is the connections between the people that have commented on the video. So here each dot represents a person who commented, blue for boy, red for a girl, sorry. And there's a line if the two people are connected as friends in YouTube. So you can see what's going on behind the debates in YouTube videos. Okay, so the question that interests me is why hasn't the uptake of webmetrics methods, digital methods, designed by social scientists for social scientists, why haven't they been more widely adopted across the social sciences? So within information science, the discipline, I think there is uptake of webometrics. Maybe not huge, but there is notable uptake of webmetrics. But outside of information science, I think there's relatively little, and it's also in the wrong places, I think. So one of the most known, I think, initiatives from webmetrics is the World Ranking of Universities. So this causes the biggest ripples in Google searches, certainly. So this is a ranking of universities by their web presences, produced by the team in Madrid, Isidro Aguillo's team in Madrid. And this is a very brief, I'm not competing with Peter's citation analysis earlier, but this is a very brief citation analysis of non-library and information science articles citing webometrics. So if webmetrics has a big uptake outside the social sciences, then this would be reflected to some extent by citations in social sciences articles. But the numbers are really low. So computing is the biggest user of webmetric research, and it's really not designed for computing at all. It's designed for social sciences. So we have some in communication and media studies, health and medicine, but just over 20 in sociology seems to me too little. Makes me very upset.
What is the 80 mean? 80 over what period, or what is the media and communication studies? 80 sites?
It's over about 8 years, I think. 8 years altogether. So yeah, that's
Maybe 3 people.
Yeah.
Same one.
Yeah. So it's interesting to look at similar research areas that do similar things, but that ignore the output of Webometrics. So in computer science, there's a lot of link analysis research that completely ignores Webometrics. They don't care about it, even though most of Webometrics is about link analysis. In sociology, there's a lot of research into networks and web networks, but it almost completely ignores the Webometrics web networks research. So there's Richard Rogers' issue networks and issue crawler software. I think that's widely used in sociology, especially in Europe maybe. And it completely bypasses Webometrics, which to me is a little bit strange. And little published in journal, maybe more published in books and books and book chapters, humanities research maybe. And less interesting than physics and complexity science, I think. But the physicists that we heard earlier, I think the physicists don't cite outside their discipline so much. Okay, so I think the wider question is, so I tried to present the case that Webometrics is interesting, it's for the social sciences, it addresses social sciences issues, and it's a set of methods and tools created by social scientists, but it doesn't have the wide uptake in the social sciences despite this. And I think the wider issue is, for digital methods, what are the reasons why digital methods can emerge and then not be adopted widely? Not just for Webometrics, but I think it's a major issue for the whole of digital social science to think about the issue of why the methods don't get used more widely, or which methods get used widely, which methods don't get used so widely, and what are the reasons for this. So I don't have the answers, so I'm hoping that the questions will have the answers with the comments, please. Okay.
Thank you very much, Mike. I think we have time for one or two questions or answers. This first,
when I listen to this presentation, my immediate response is, this is a method in search of a problem. When I think of methods that have actually had a major impact, think of log linear models, they're connected very closely to an important substantive problem that a lot of people are concerned about and are searching for a way to find a better answer to. And in the case of log linear models, they're probability tables. Because a lot of the research is linked to people trying to say things about various kinds of mobility tables. And I think you can do the same sort of thing, the link between, for example, the development of factor analysis in the early decades of the 20th century and the intelligence testing, for example, is similar. You can think of, you can probably come up fairly quickly with a half dozen examples of methods that rose to prominence because there was an important problem that they helped solve. And I didn't see an important problem up there.
Okay, thank you. No, that makes a lot of sense. So there are problems which I think information scientists would think are important.
But your sociology
yeah.
is, I agree.
Yeah, this is.
Not many, but where's the problem?
Yeah, I hadn't thought of that.
I disagree with that slightly, only because all innovation comes from users who find tools and then figure out whether or not they can apply them to a problem. So I don't think you need to figure out the problem first. We should keep building the tools. And then
Okay.
I think there's some real semantic issues here, though, because social network analysis is a very large area of research, and it may be that there's simply a lack of bibliometric connections between them, where in fact what you're doing is much more sophisticated than some of the social network analysis, and that the kind of methodological sophistication that comes out of the history of the network's bibliometrics that you're applying here, as opposed to very slapdash kind of, oh, isn't this cool data, without any sense of the provenance of it. So to what extent is the work being done and simply not citing by name this work? And to what extent are the methods being adopted, but being adopted naively from an area where they're actually fairly rigorous?
Okay. Well, this is just my opinion. But so I think in the some of the sociology research with networks doesn't have the kind of methods focus, so they're not that bothered about the accuracy of the methods and the care with the methods. So, and I think they just don't know webmetrics research exists, and they don't really care because they've got something that works reasonably well and gives them interesting results. So I think it's not critical that it's like the most accurate it can be. It's using the best methods it can. The most critical thing is it's fairly easy to use, and what it gives is interesting.
I would argue yours is more reliable and more valid.
Okay, thank you. I will be quoting you a lot on that.
Quick comment or question?
Yeah, I just want one quick question. You said that it was very similar to the scraping and and I just wondered if you could say why they might be being used more. What your take on that is? Why should it be that the scraping might be used more or more popular, or why computer scientists aren't looking at this?
Well, for the sociology, for the issue networks people, I think they have their own. They've got their own method that comes from within their own field, and it works for them, so they're not looking out of the field. So I'd like to blame them for not looking further.
Is it that
But
similar? Is it that similar that you could?
the outputs are fairly similar, yeah. So there are webmetric programs that produce your network diagrams of the links between websites, and then that's the same thing that Issue Caller produces, for example.
So
And
reinventing something going.
yeah. So almost duplicate in the functions, but different key principles going into the building of them. So if you look underneath, they're quite different, but the surface product is quite similar.